The given question is a material particle is chasing another one and both of them are moving on the same straight line. After they after they pass a particular point, their velocity v varies with time as shown in the figure. When will the chase end? চেষ্টা end কখন হবে? The given options are 4 second, 6 second, 12 second, and fourth option is insufficient information. So if we analyze the question and graph simultaneously or same time, so we can see that here it is given our velocity versus time graph. These are velocity versus time graph. So let this is, and here the 0.3, 0.4, this is what? This is nothing but the time in second. This is a time scalar given. And let this is our particle 1. This is our path of the particle 1. And this is our particle 2. This is indicating our particle 1 and this is indicating our particle 2. Now, for solving this question, we have to use some important or useful concept here. The concept behind this question is, first of all, we have to compare the slopes of the paths. First of all, we have to compare the slopes. If we compare the slopes, then for the first particle, which one is the first particle? This one is our first particle. This blue colored one is our first particle. So its slope, we can determine its slope. So from this diagram, we can say, so what is the slope? What is the meaning of the slope of velocity versus velocity of time graph? It is nothing but the meaning of the slope of the velocity versus time graph is nothing but that is the acceleration. So, or we can write its acceleration a1. So acceleration of the particle 1, let it is denoted by the symbol a1. So a1 equal to what? It is nothing but change in velocity divided by change in time. So it should be what? This is our first particle. So its slope, it is indicating our slope a1. So a1 equal to what? What is a1? What is a1? a1 is nothing but v divided by 4 equal to v divided by 4. Because this is our v, this is our velocity, this is our velocity v, and this unit equal to up to this point. It is nothing but this is 4, and this is our up to this equal to v. So acceleration a1 equal to v divided by 4. And again, if we compare, if we find out the acceleration for the second particle, so what should be the acceleration for second particle? Now let us consider this is the path for the second particle or graph for the second particle. For the second particle, again we can find out the acceleration of the second particle in the previous as like the previous manner. In that case, our acceleration a2 should be equal to what? What is the acceleration? Acceleration is nothing but change in velocity divided by change in time. So its slope should be equal to up to this height. This height equal to same constant as the previous one for like a1. So a2 should be equal to its height, that is equal to v divided by height divided by its change in time. So for the first one, the time is from, let this is 0. For the a1, its time change equal to from 0 to 4. So change is equal to 4. And for second particle, it is up to, what is the change? For second particle is starting from the point 3 and this point meets at the time 4. So change in time equal to 4 minus 3, that is equal to 1. Or we can say a2 equal to what? a2 equal to only v. But what is V? From this first equation, we can again write this V equal to 4A1. V equal to what? V equal to 4 times A1. And again, we can substitute the value of V in this equation. So if you substitute the value of V in this equation, then we can say A2 equal to what? A2 equal to 4. A2 equal to 4A1. A2 equal to, now this is nothing but the relation. Up to now, we established a relation between the two accelerations, that is A1 and A2. Now, we have to consider, or we have to think about when the chase ends. The chase ends when displacement are when displacement are same. Chase ends when displacement are same. So that is, it means, or we can say that is, let us displacement covered by the first particle, means first one, is equal to S1. When chase is ending or it ends, we can say at that particular case S1 equal to distance covered or displacement covered by the first particle equal to displacement of the second particle, or we can say S1 equal to S2. Now we can write the kinematic equation for the displacements. That is what? S1 equal to what? What is S1? Instead, in place of S1, we can place here S1 equal to what? V1. V1 plus V1t plus half A1 t square. And instead of, in place of S2, we can write what? We can write, what is S2? S2 is nothing but V2. What is S2? What should be S2? S2 is nothing but V2. We can write the kinematic equations here also again. So we can write here, this is nothing but V2t plus half A2 t square. Now for the first particle, from the first particle, if we consider for the first particle, it's start from the initial with zero initial velocity, because this is the pathway of the first particle and its starting or initial velocity is equal to 0. Therefore, we can cancel out this one V1t. And for the second particle, for the second particle, what we can say? Second particle, it is starting from what starting velocity? It is also from 0. So V2 is again equal to 0. So this two part will be cancelled out. So if this two part will cancel out each other, then we can say this half, the remaining part is equal to half A1 t square should be equal to half A2 t square. Now there is a relationship between A1 and A2, which we already established previously. Now we can substitute here, or we can substitute A2 in place of A1, or we can substitute A1 in place of A2. So let us substitute, we're substituting the value of A2, and we're writing A2 in terms of A1. Then this equation will take the form. Now this equation should be equal to, now this half and half will cancel out, and this, but these two t are not same. So we cannot cancel out these two times. So we can say the first particle, it is what? It is our A1. It is what? It is our, for the first particle, it is our A1 into t square equal to, for the second particle, what is A2? What is A2? A2 is nothing but 4A1. So we can write this value, A2 equal to 4A1 into, what is t? What is t for the second particle? Time for the second particle. It is nothing but, it is shifted. Now we can see the second particle second particle starts 3 3-second advance, in 3-second advance. So from the transformation theory of graph, we can say that if any graph starts in advance, then for finding its equation, it should be minus. And if it is if any graph starts lagging, then it should be plus. Now, as we are seeing that this time, now we're taking the time taken for the particle 1 is t, and time taken for particle 2 is t, is this t. But this is for particle 2, the time is leading. When the time is leading, then it should be plus minus, and when time is lagging, it is minus. So as we are seeing that the time for the particle 2 is in advance of particle 1 in what unit? The unit is 3 unit. So we can write there the value of time for particle 2 in terms of particle time for the particle 1, that should be equal to t minus 3. We can get this from the graphical transformation theory, equal to this one. And if we solve these equations, then we can cancel out this a and a, or we can write this t square, which is equal to t minus 3 whole square. Or if we split this one, then we can write this should be equal to t square minus 6t plus 9. Again, we can cancel this tt from both sides, or we may or may not cancel. So if you cancel this 2, then we can write this, we can take this 3 as common. We can take this 3 as common. If you take the 3 as common, then we can write what? We can write this. If we take 3 as common, then you can write here 2t minus 3 equal to 0. So if we solve this equation completely, then what would be the solution for this equation? We can write the solution of this equation as t minus 3 whole square equal to t square. So what should be its solution? If we find out the solution, then we can write here t minus 3 whole square minus t square equal to 0. Or you can again write this t minus 3 plus t into t minus 3 minus t. T minus 3 minus t equal to t minus 3 here and minus t. But one of the t cannot be 0. So this is not our valid way. So what should be our valid or proper time? So if you are solving in this way, what we are saying? So it is, if we split this in the form of the t minus a plus b, a square minus b square, then it is a then it cannot give our solution, the proper solution is of this question. Now we can, so instead of that we can use here the quadratic equation. If we solve this equation using quadratic equation by minus b plus minus under b square minus 4ac by 2a, or up to from this point, what, that is t square equal to t minus 3 equal to 4 into, oh, there is 4 which is missing here. So you can write t square equal to what? T square equal to 4 into t minus 3 squared. Or we can say this t square. So this t square equal to plus minus 2 into t minus 3. This t equal to. And if we solve this, if we take the positive sign here, then we can say 2t minus 6 2t minus 6 equal to what? We can say 2t minus 6 equal to t. 2t minus 6 equal to t. Or we can say t equal to what? Then its value should be equal to t equal to 6. 6 equal to the value of t. And if we take the negative sign, then we can find this minus 2t, or t equal to what? T equal to minus 2t minus 2t plus 3. So in this case, t is now becoming equal to what? And this it should be 6. And in this case, t is now becoming 2. But from the analysis or from the given condition of this question, we can see that the motion, the condition is the 2 is not acceptable. Why it is not acceptable? Because the reject as second particle does not start till 3 seconds. Because second particle starts the motion after 3 seconds. So 2 seconds is before the starting time of the second particle. So it is not our acceptable answer. So our acceptable answer is equal to only t equal to 6 seconds. So in our option, in our given option, there that is mentioned in our option B, which is our right answer.